Let's try to understand the tree data structure and the queue. And today I'm going to explain the problem of a right view of binary tree. And I have already explained this in other videos in a playlist logic building. But this is going to be long video. So if you have not understood there, then you can come back and watch this. I'm going to use the golang for this. So let's see the problem once again, and then we'll start writing the code. So this is the problem, and last time I solved this in a Java and Golang, so you can check that in a logic building, and then you can, if you have any issues, you can come back again with this long videos. So with this binary tree data structure, and if you understand this problem, then we can easily find the right view or in the left view. So we can solve multiple things, or if you want to, there is another problem in a leetcode, like find in the max in each row. So that's also, it will be easy to find, because this traversal here it's a row level order traversal. So first we'll get this tree, and then we'll read one row, and then we print or do whatever the operations we want, and then we can go to the second row, and we can go to the third row. So that's a traversal we are going to follow. And if you want to use, like, you want to see the right view or the left view, then for that purpose we'll use the queue. So let's do first the row level traversal and print this item, and then we can add the queue data structure, and then we can implement the logic how we'll do the right view or left view. So let's see the code. So it's I'm going to create the same tree in a golang first. So it's a 1 2 3, then 4 5. Okay, let's do that. Okay, so for the tree I'm just going to create a struct for this. 5, it's a tree and struct, and say the item int, and then the left is a tree and the right also a tree. Okay, so that's the structure where I'm going to store the left, right, and the item. That's a val or item, whatever we say. Okay, so let's bring this tree structure. So first is the 1, and then it's the left side is the 2 and the 3. Let's see once again, 1 2 3, then it's the right side 5, right 4. Okay, so 4, and then it's a 5. Okay, so let's create this tree first. So I'll create the root here, and it's a tree, and item is the 1, on the left it's a 2, right is 3. I can create that 2 here, 2, and for right side for the 2 is 4. So right to 4, I can create the 4, item equal to 4. Then for 3, I can create another node, so 3, item 3, and the right side of 3 is a 5. So it's the right is, so 5. Okay, so the tree structure is done. Now let's print the row level. So for this here, let's create a function first. Function so let's say display, and I can pass root here. So for this root, it's a tree, and we're just going to display, or just put the row level traversal, and I can call this function row level traversal. I can pass root here. Okay, so for the row level traversal in a binary tree, we usually we'll usually use two loop. So in a first loop, so let's first, before that, let's create a data structure queue for this. So I need to import this container list, and then you can come here, and what we do, we store the first item in a queue. So I'll go and create the data structure queue. So queue, then list.new, and I will add this first item in a queue. So it's a queue dot back root. So we already added the first item, so we know this queue is not empty. So by knowing this fact, I can use the loop here, queue dot len greater than 0. Okay, so we have the first item. This one, we have the first item in a queue, and the queue len greater than 0. So that's good. So now I can create another variable here. So like queue len, and then in this I can store the length of this again for the inner loop. Let's say queue dot len, and this queue len is 1 this time, and this is also 1. So we are inside this loop, and we also stored that size in a queue len, and I'll create another for here. I can say here queue len greater than 0, then come inside. So first we get item 1. So we got the item 1 in the outer loop, and then for inner loop, now we are processing, and we'll remove the item, and as soon as we remove the item, we decrement this queue len, and we say that okay, if it is 0, then do something like print, or because we got the row. So when the inner loop, this queue len is 0, that means 1 row is done. So in a 1 row, what you want to do, you want to collect the items, display something, or whatever you can do. You can find the max of this row. So those kind of things you can do. So queue len is greater than 0. So here let's remove the item first. So element and queue, and from the queue we always remove the item from the front. So queue dot remove front, then convert this to the tree, element dot star tree. So we got the item, and so as soon as we remove the item from the queue, we can decrement this queue length. So now the queue length is 1. So this time we can check if queue length is 0. So that queue length is 0, that means one row is done. What we want to this time, we want to print those things. So queue length is 0, so in order to print we can store that row in some variable. So let's create a variable here. Before printing, I can store this all items in a variable. So let's say var row. So row item, and it's going to be this. So as soon as we get the item, we can store in a row. So row equal to append row dot node dot item. So we got the item queue length 0, print this item. 20 println row equal to row. Okay, so we printed the item, and we can do one more thing. So after the printing, for like we got this one store and we printed, because this queue length is 0, that means one row is done, we printed. But we also need one additional thing. So we can check if there is a left item for this node or right item for this node, and if you find the left and right, we can add this in a queue, because we know the queue is 0 now, queue is done, we process this. So if you add this left and right, then the second row is already in a queue, and then we'll get stuck with the outer loop, and then again we'll process for 2 3. So let's do that first. So if this node dot left equal to or not equal to nil, then we can add this queue dot push back node dot left. And the similar thing we can do for the right. If node dot right not equal to nil, queue dot push back node dot right. Okay, so in this way, we also added 2 3. We also added 2 3 in a queue, and here we see the inner loop. The first time the queue length was 0, and then queue length 0, that means we printed the row and then also added the other items in a queue. So the inner loop is done. But again it will come back and get stuck in outer loop, and the queue length, this time the queue length will be 2, and here also queue length be 2. So the inner loop, again it will run for that 2 items, and we'll get one by one item from there, and we'll decrement this. And if you remove 2 from the queue and the 3 from the queue, and then the queue length will become 0, and then we can print this item. So queue length inner loop, so queue length 0, and we can print that row. And then after printing, again we can check if there is a left and right for that item, left and right for that other node item. We can add that in a queue, and this is the process. Let's run this first, and we'll get more confidence. We'll check for the syntax and other things. So it's a main go 20 5. Okay, so this is item. Save it, run it again. Line number 42. Okay, item. This is the item. Save it. Yeah, so you can see the row is 1, So another row is 2 3, another row is 4 5. So this is called row level traversal. So once we have this idea, row level traversal, now we know that we can iterate from this, we can iterate from this each row. So we can add the other logic, like if you want to find the max of this, then we know that in this place, this is the row we have already collected, so you can find the max of this row. So that's logic can be easily done there. If you want to see just only the right view things, for the right view, then we can check here, like if you once the we have the one item, and when the row is done, like row is done, then in that case it's a queue lane will be 0 and the last item is 1. So this last item is a 1, so we can collect this item. That is the right view. Again when the queue lane in the inner loop becomes 0, so in that case we have 2 and 3, and the last item is 3, because we add first left and then we add right. If you collect that item, that is going to be the right views. So let's do that. Like it's easy to do that. So right views, I can create a variable. So let's create variable here. So one is var right view, so int. So come back again in this place when queue lane is 0. So when queue lane is 0, that means that row is done. And if the row is done, so the last item, we can collect that item there. So row is 0, it's a right view, go to append right view, and this node dot item. So right view. Okay, so in this way we collected the right view, and let's print that right view. So I'll come back outside of this loop and I can print right view. Let's run this, save and run. So if you see, the right view is 1 3 5. So we can see the 1 3 5. So in the similar way, like if you want to display all like left view here, so if you see in this side, that's the left view 1 to 4. So we can just change the logic a little bit here. So for the left view, what we can do, this thing, like when row is done, then what we usually do, we'll store this left item first and then right item first. And when this row is done, then we'll check with the last item was 3. Here also row is done, last item was 3, and we collected 1 3 5. So that's the right view. For the left view, what we do, we add this item, that's also in the left view, and then this row, once the row is done, then first we add right item like 3, and then we add 2. So in that case, the 2 is always the last item for that row. So when the row lane is 0, we collect this in a left view. In the similar way, we'll go to the another row, and then we first add the right 5, and then we add 4. So the 4 is always going to be the last item. So if I change this logic here, if I put this right on the top and left below, then that will be the left views. Let's do that. So variable is right view, but internally we know we are going to get the left view here. So let me change that also for the better name. So let's say I'll put that left view, and here also left view, and here also left view. Save it and run it. Yeah, so we can see the left view here, 1 to 4. Come back here and you can see the 1 2 4. So this is, this is very much necessary to understand, how we are traversing in the row level wise, because with this, there can be many interview questions can be formed, and once we have this knowledge of row level traversal, then we can solve multiple problems. So this very much basic stuff in this tree data structure. So now I think you can try yourself, how to find the max in each row. You can collect that max in each row, like let's say 1 here max, 3 here max, 5 here max. You can collect that, you can print that, or the mean in each row things. Yeah, so I hope you have understood this thing, and I think I explained in every possible way, but you can just try yourself and see that you can try in any language, that's the same logic. So that's all for today. Thank you.